Hello friends, today's video is over equations of motion. That means equations of uniformly accelerated motion. That means I want to say that this is equations of uniformly accelerated motion. Uniformly accelerated motion. See here. Uniformly accelerated motion means suppose body is moving from A to B in 1 second 5 kilometer, B to C in 1 second 7 kilometer, C to D, that is also 1 second 9 kilometer. That means its velocity is changing uniformly. A body is said to be in uniform acceleration if it undergoes equal changes in velocity in equal successive interval of time. You see that equal changes in velocity. First 1 second it is traveled 5. Next 1 second 2 kilometer increased. Next 1 second 2 more kilometer. That means this is the uniformly accelerated motion. So today's topic is equations of motion. I am not going to back. I am explaining about the equations of motion which is related with a uniformly accelerated body. This topic is motion. This is purely about the one dimension. That means the body which moves with a uniform acceleration in a straight line. This is related with the one dimension. That means in a straight line. Okay, if it is the two dimension, that means you have to think about the plane, but this is purely one dimension. So for a body moving with uniform acceleration, see here, for a body moving with uniform acceleration, we get three equations. Okay, which shows the relation, which shows the relation between initial velocity final velocity distance traveled acceleration means uniform acceleration, this is the third point, this is the fourth point, fifth point is the time taken. See here. For a body moving with uniform acceleration, we get three equations. Those equations establish a relationship between initial velocity, final velocity, distance traveled in a particular direction, you can say the displacement, acceleration means uniform acceleration, and time taken. Okay, so what are the three equations? The three equations are V equal to U plus AT, S equal to UT plus half AT square, V square minus U square equal to 2AS. These three equations are called equations of motion. It is related with a body which is moving with uniform acceleration. That means it is in a straight line only. Clear? So now I am going to derive these three equations with the help of graph. I hope that you will watch this video carefully, and children, those who have not subscribed this video, I am expecting you subscribe as early as possible. As a result, you can get the notification in right time. Okay, let us move to the derivation. So, I am going to derive these three equations of motion from the velocity time graph. Velocity versus time graph. So, derivation. From where? From velocity versus time graph. Let us see. From velocity time graph. So, consider a body moving with a linear velocity, means moving in a straight line. Okay. It gets acceleration in time t. Okay, or I can write that it gets acceleration in time t. Okay, where its final velocity is v. That means, so uniform acceleration I am writing, better you write a in time t. That means initial velocity u, final velocity v, time t, acceleration a. Okay. So I have written here from velocity time graph I have to derive these equations. Okay. Now you see that. This is x-axis, this is y-axis. Okay. So this point is A. Suppose at the point A, its initial velocity is u. Okay. The body has moved from A to B. The body has moved from A to B. See here, from B I am drawing one perpendicular to the x-axis, and here also perpendicular to the y-axis. Okay. So this is the A, this is B. Suppose I can write this point is A. C. Okay, here you join it. This point is suppose D. This point is E. Let us see. The body has travelled from the point A to point B. When it is at the point A, its initial velocity is u, and when it is at the point B, its final velocity is v. So I can say that here the velocity graph, here velocity time graph is a straight line. You see that AB is a straight line. In the x-axis I have taken the time. In the y-axis I have taken the velocity, because this is a velocity time graph. So time we have taken in second, velocity we have taken meter per second. See here. Now OA represents initial velocity. I can say that OA equal to initial velocity. That means at t equal to 0. Clear? OA is the initial velocity at t equal to 0. What about the OC? OC equal to final velocity at t. Listen carefully. O to C represents the velocity v, whereas O to A represents the velocity u. I have written OA initial velocity at t equal to 0, and OC is the final velocity at t. So here to here this distance is t. So this point D, the time is here 0, time is here t second. So I have drawn the perpendicular from the point B here to here, x-axis. This is the t second. Okay. So now let us move towards the derivation of a first equation. Okay. So what is the derivation of first equation? You see that. Now this is the velocity. This is the time. That means this line represents the velocity. This line represents the time. I am going to find the slope of the line AB. See here. Here acceleration is equal to slope of AB. Why I am going to find the slope of AB? Because you know the slope is the tangent. That means the perpendicular side by base. In this triangle you see this perpendicular side by base. Whenever I am telling about the perpendicular side, I am telling about this velocity. Whenever I am telling about this base, I am telling about the time. Okay. So acceleration I have written slope of AB. So I can say that the slope of AB is equal to BE by AE. This is equal to BE by AE. See here. Perpendicular by base in this triangle. So B by AE, in place of B I can write CA. I can write CA divided by, in place of AE I can write O to D. O to D. Okay. Implies that in place of acceleration I am writing A. In place of CA, I am writing CO minus. Okay, I am writing it CO minus AO divided by OD. See here, CO. That means that is also BD. That is also BD. Okay. So I have written B by A, BE by AE. In place of a B, I can write CA. I have written CA. In place of a AE, I can write OD. And in place of CA, I can write CO minus AO. That means CO represents the final velocity, AO represents the initial velocity, OD represents the time. Clear? Implies that V minus U is equal to AT, or I can write that V equal to U plus AT. This is the derivation of first equation what I wrote, V equal to U plus AT. I hope that you might have understood it very clearly. So you copy it. Now I am going to rub it. Next I will explain the remaining two derivations. S equal to ut plus half at square and v square minus u square equal to 2as. So I am rubbing it. Let us see here. This is the motion in one dimension. See here, second one. What second one? S equal to distance traveled in time t second. S is the distance traveled in t second, that is equal to area of the trapezium. Which trapezium? OABD. OABD. I have written the distance traveled in time t second. At the same time I have written area of the trapezium OABD. Why I am using the area? Okay, I shall explain it. See here. Now, first I am deriving, then I shall tell the reason why the distance is equal to area covered by this trapezium. Okay, so area of the trapezium, here I am dividing it into a rectangle and one triangle. So I can say that area of the rectangle OAED plus area of the triangle ABE. This is equal to area of the rectangle OAED, that means OA into OD, length into breadth, OA into OD plus half into base into height. I am taking, suppose this is the base, this is the what? This is the base, this is the height. Or I can take this is the base, this is the height. Does not matter because this is the 90 degree, this is a right angle triangle. So in this case half into base into height. So I am taking this is the BE into AE. Okay. Or in place of a BE, I can take CA. In place of a BE, I can take CA. In place of a AE, I can take OD. Okay. Let us see here. So OA into OD plus half into, in place of a BE, I am taking CA. In place of a, okay, AE already have taken, so in place of AE I am taking OD. Let us see here. So OA represents the U, OD represents the T plus half. In place of a CA, I am taking this is CO minus AO. into OD. Okay. So it is better, next step I shall change it, OA into OD, let it be like this. So in place of a CA, I have taken CO minus AO because I want to bring the relation between UV, AT like these terms. So that's why I have used C2O minus A2O because it will give the V and U into OD. Okay, now we put its value. In place of OA I am taking U, in place of OD I am taking T plus half into CO. CO represents the V minus AO represents the U, okay, into OD represents the T. Okay, did you understand? देखो, see here. Before that I said that acceleration is equal to v minus u by t. That means I can say that v minus u is equal to at. See here. So I am writing ut plus half, in place of v I am writing at, v minus u, at into t. Why? Since v minus u is equal to at, so this is equal to ut plus half at square. Clear? So I can write that s equal to ut plus half at square. This is the derivation of a second equation. Okay, here s is the distance. Okay, so one thing I can make you clear, why I have taken the distance traveled is equal to area of the trapezium. Okay, let us see here. This is actually a velocity time graph. See here. Here velocity is taken, here time is taken. You think that this is the length, this is the breadth. Clear? So to find the area, we take length into breadth. Suppose this is the rectangle. I want to find the area, so I have to multiply length into breadth. In place of length, here velocity is there. In place of breadth, here time is there. So I am multiplying v with t. Already we know that, see here, velocity is equal to displacement by time. So whenever I am multiplying velocity with time, that means I am getting the displacement. So displacement is equal to velocity into time. In place of writing velocity into time, you can think that this is length into breadth. Okay, that means it gives the area. Here also in case of triangle, we can think like that also, because half into base into height, I am multiplying this one with this one. Okay, this is one of the way. Other way is there to the integration that in a higher class level you will not learn. Okay, that means you can make it a small rectangle also. You think that very small rectangle you can make. Length into breadth also, here it is also coming. That's why in place of a distance traveled in t second, I have written area covered by the body when it travels from initial velocity to final velocity. Okay, so AB is the straight line. That means the velocity time graph is a straight line. Already I said that. Okay, this is about the second equation. So I think that you might have understood. I am going to explain the third derivation. That means v square minus u square equal to 2as. Let us see. See here. So s is the distance traveled in t second. This is equal to area of the trapezium OABD. So trapezium formula what? Half into perpendicular distance between them. I can write half into height between them, or you can write here in this case half into AE. Okay, into sum of the two parallel sides in this figure OA plus dB. So half into perpendicular distance into sum of the two opposite parallel sides. Okay, so in place of AE you can write a half into OD into OA plus DB. In place of DB you can write OC because this one parallel. See here, so B to D how much, C to O also that much. So in place of OA I have written OA, in place of DB I have written O to C. This is equal to half into OD, that means half into time. Okay, into OA. OA represents what? OA represents U plus S OA plus OC I have written, correct? Okay, OC represents, this is the V. Okay, clear? So I know that acceleration is equal to V minus U by T, or V minus U equal to AT. So here V minus U equal to AT, or I can write that T is equal to V minus U by A. So here you see 1 by 2. In place of T I am writing V minus U upon A, and here U plus V, or you can write V plus U. Okay, does not matter. So this is equal to half, this is V square minus U square, V square minus U square divided by A. So in this case what I have taken, A is equal to distance traveled, that means A is equal to half V square minus U square by 2. A implies that V square minus U square equal to this 2A multiplied with S, 2AS. Clear? So I can say that V square minus U square equal to 2AS. This is the third derivation. Once again I am repeating this one. See it. S is the distance travelled in T second. That is the area of the trapezium OABD. So I have taken half into perpendicular distance between the two parallel sides, that is the AE, into sum of the two parallel sides OA plus DB. Okay, so this is half. In place of AE I can write OD. Okay, into OA plus OC, that is OA plus BD. In place of BD I have written OC. Clear? So half OD represents T, this is OA represents U, OC represents the V, U plus B, half into T. In place of T I have written V minus U by A. If you want you can mention here, since T is equal to V minus U by A. Clear? From the first equation we got this one. Okay, So it is better I shall repeat because I mentioned there already. So half into b square minus u square by a. If I do the cross multiplication, b square minus u square equal to s. This is the third derivation. These three equations of motion are very important from your exam point of view. Okay, these equations we can derive in alternate method, but so far as the CBSE or ICSE syllabus is concerned, so this is compulsory. Due to request of some students, I explained this. I hope that you might have understood this concept clearly. Until the next video, bye.